Hello everyone, you're welcome back to my channel. Today we are going to be taking a look at what continuation of light energy, but today I'm going to be taking you through propagation of light energy. Propagations of what? Light energy. Now if you are new to my channel, don't forget to subscribe to my channel and also click on the like button to like my video and share the video with your friend. Thank you. Let's continue. Now, talking about propagation, in my previous video I told you that propagation simply means movement. Movement. Now, we normally make use of this statement mostly when we are referring to light energy, to light. Anything that related to light, we talk about propagation. Now, you see, we're going to be taking a look at propagation. You see, light energy will continue to move in a straight line. All together. Light energy will continue to what? Move in a straight line as long as it remains in a medium of uniform density. I said as long as it remains in what? Medium of uniform density. When it leaves that medium, it might propagate in different direction. Let me show you something here. Now, in physics, there are three different kinds of medium that we might have in physics. We can have a gaseous medium, we can have a solid medium, we can have a liquid medium. Now, light energy, as you also know, is an example of an electromagnetic wave which does not require a material medium for its propagation. What it simply means is that what? Light can travel in a gas, it can travel in solid, it can travel in what? In liquid. Example of gas is air. Light can travel in air at any what? Now, light travels in a vacuum. A vacuum is a medium that does not have any material in it. It is a what? Vacuum. Now, if light is meant to travel in a vacuum, light travels at a constant speed of 3 times 10 raised to 8 meters per second in a vacuum. Altogether, now it has the fastest speed. Light has the fastest speed when it is traveling in a vacuum, but it has the slowest speed when it is traveling in any of this form of medium, either solid or what? Liquid. Now let's continue. According to what I said just now, okay, we can also assume that gas is what? A medium, a vacuum, right? Because a vacuum has a density of 1.0 and the density of air is also related what? Approximated to 1.006, which is approximated to 1.0 also. So we can use air as vacuum altogether, but air is never a vacuum. Thank you for what? That. Now, so we said light can travel in a straight line as long as it remains in a medium of uniform density. Now, which of the medium is of uniform density? Now, if light is traveling in air, it continues to move along a straight line. And anything that makes light to change its medium from air and move to solid, especially if you're talking about a glass block. If light is traveling in air, it continues a straight line, but when it's got to an interface between air and another medium, which is a solid, light tends to bend. Altogether, the process at which light bends when it enters, when it's moved from one medium to another medium, that is what we call refraction. Refraction of light. But if there is no any other medium, light will continue to move along that same straight line. Now, why is it that light can also move in this what? Why is it that light can enter into this material? Because I gave you that we have 3 types of material. This glass block here is an example of a transparent material which allows light to pass through it. Thank you so much. Now, assuming it's an opaque material, that light will never pass through it. What happened to it? It is going to what? Come backward. It's going to reflect backward. Are you getting it? If it's a transparent material, the light is going to reflect backward using the process of what? Reflection. Reflection. Why? Because an opaque material does not allow the light to pass through it. Rather, it rejects the light off. I want to get out like that. So that is one thing about propagation of what? Light. Light can travel in a straight line as long as it is in the same medium. The same medium. It will continue to travel in that same medium along a straight line. But when it's changed the medium into another medium, light is going to deviate away from a straight line. Thank you so much for what? That. Now, let's continue. Now, one of the major applications of what? Propagation of white light. That means one of the major applications of this propagation of white light is in shadow. 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 Now, we knew that shadow is always formed when the path of light is being blocked. Now, when you block the path of light, the passage of light, it formulated a shadow. A shadow is just a dark region. Are you getting a dark region that is what that is formed due to what reflection, due to the blockage of what light by an object. Are we getting what I'm saying now? Now, before I move on to what explain this object for you, I would like to introduce you to two things altogether. When I was referring to source of light in my previous video, now this I said we talk about luminous and what non-luminous. Now, on that luminous source of light, we can have the source in different form. We can have it as a point source of light, or we can have it as an extended source of light. Extended source of light. Now, talking about the point source simply means, let me just have something of this kind. I have a point, are you getting me? That is removing light energy, or let me say it is just bringing out light energy, a single point that is bringing out what? Light energy. This is a point source. We can have an extended source like your bulb. Your bulb can serve as an extended source whereby light can be removed from different parts of the bulb. This is an extended source of light energy whereby we can have something of this kind. Now, this is an extended source of light energy. This is a point source of light energy. I want to get up like that. Why did I do these two sources for you? Because I want to use it to explain shadow. Are you getting what I'm saying now? Now, when shadow, for example, now, I said a shadow is always formed when an object, an opaque object to be precise, block the passage of light. Example of a human being. You know, sometimes when we stand in front of what light, we see our shadow at the what side here. Now it is due to reflection. Why? Because light can only have they only have the ability to travel in a straight line. They does not have the ability to what? Curve. Are you getting what I'm saying? They can't curve an object. You grab, so they can only move along a straight path. All together with me like that. Now, so in this case here now, we can have a shadow. If I have an object here, this is an object, this is a point object. If a point object give reflection of light to this object here, now this is the object here. Now, because this object here is an opaque object, what happened to this light? No light will be shown in the other side. Let me ask you, we have a screen here. Nothing will be shown on the screen. Now, the reason why nothing is shown on the screen is because this object has completely blocked the passage of this point source of light. So, nothing will be shown on the screen here. Now, we said that we'll be having a total darkness at the back here. Total darkness. Now, this total darkness that is formed by shadow is what we call umbra. Umbra region. That means shadow can form different kind of region. It can form a region of total darkness. A region of total darkness that is formed by a shadow is known as umbra region. In this region, no light will be shown at all. Now, but if I have an extended source of light energy, like this, extended source of light energy like this, like your bulb at home. Now, if I have an object here, it reflects light in different direction, like this. Now, in this case here, an extended source of light energy is going to produce two regions. It will produce two regions. The first region is this region and this region. The other region is now this region that is here. This region here indicates that the light is completely blocked by the object. This is the object O altogether. So this region here that you are seeing here is a region of total darkness, which is an umbra region. Why? The second region is this two region that is here. This region and this region here, let me say region A and region B, which is here. There is little light that is being shown in that region. These two regions are known as what? Penumbra region. Penumbra. Now, a penumbra region, penumbra region. A penumbra region is a region of little light. I get me? I hope you're like that. It's a region of what? Little light. Now, this thing is always applicable. Shadow finds its own application in eclipse. Eclipse, you know, when we talk about what? Eclipse. Eclipse are classified into two. Shadow found its application in eclipse. Eclipse. Now, eclipse are classified into two. There are two different forms of eclipse that we have. We can have the eclipse of the sun, which is known as annular eclipse. We have an annular eclipse, and we can also have a lunar eclipse. Lunar eclipse. All together. So eclipses are classified into what? Annular and lunar. Lunar eclipse. Now, when we said annular, what is by annular? Take a look at something. This is where the confusion what comes about. Now, when we talk about annular eclipse always occur when the moon come in between the sun and the earth. As you also know that the sun is luminous, while the earth is what? Non-luminous. When the moon come in between the sun and the earth, I have the moon here. Don't forget that the moon is a smaller object, which is even smaller than the earth, but the earth is smaller than the sun. Now, the sun is here, while the moon is here and the earth is here. When it's come in between the moon coming to be in between the earth and the sun, it produces what we call a solar eclipse. I get something now? Now, a solar eclipse is what is known as annular eclipse. Now, take a look at this. Don't forget that this is a source of light. Now, this source of light can produce light along this direction to the X, along this direction to the X, and also it can also make light to move along this direction. Like this is a ray diagram. Sorry, this is a ray diagram. This is a ray diagram. All together. Now, in this case here, it's going to be producing, when the moon comes in between the sun and the earth, it will produce two regions. Don't forget that the moon is smaller. This region here will be completely blocked by the moon shadow. Are you getting what now? So this one here will produce an umbra region, while this one is penumbra and this one is what? Penumbra, because in these two regions here, this region that is here, there will be little light. Don't forget that I said for a penumbra region, there is always a little light. And this region here, we are going to be having a little light. And here we also have a little light. But in this region that is very close, that is in front, directly in front of the moon, there is no light energy that will produce there. Are you getting me? So this kind of eclipse is all called annular eclipse. Don't forget, annular eclipse is taken as what? SME. SME. Sun, Moon, Earth. SME. That is an acronym to it. SME. To show that the moon is between the sun and the earth. Now, let me write the acronym SME. All together. Now, I will talk about the other type of eclipse, which is known as lunar eclipse. Lunar eclipse is an eclipse that occurs monthly. It is always formed when the earth is between the sun and the moon. The earth is between what? Sun and the moon. One thing is that what? Lunar eclipse does not what? It just occurs within what? Some seconds and some what? Period of time, and it's what? Clear off. Within some seconds to clear off. Are you guys understand? Now, lunar eclipse occur when when the earth is within the sun and the moon. Altogether. So when the earth comes between the sun and the moon, it's going to produce a lunar eclipse. Please take note. Lunar eclipse is SEM. 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 Altogether. X as in social, E as in what? Exceptional, and M as in man. All together. So we can have SME, SEM, and SME. Thank you for watching this interesting video. Please don't forget to click on that like button and the subscribe button, and also share the video with your friends so that they can also enjoy this from Source Arena Academy. You're welcome. See you in the next video. Thank you.